Imagine a single particle of light. It was born in the blinding dawn of the universe, ignited in the core of a star that no longer exists. For 13.5 billion years, it has traveled across the absolute zero of the expanding void, drifting through the pitch black quiet, uninterrupted, unseen, until now. A million miles from Earth, floating silently in the freezing dark, a golden mirror finally caught it. And when the James Webb Space Telescope translated that ancient, exhausted light into an image, it showed us something that simply shouldn't be there. When we look out into the deep void of space, we are not seeing the universe as it is today. We are looking backward, peering deep into the well of time. Light is the fastest thing in the universe, but it still has a strict speed limit. It travels at 186,000 miles per second. Down here on Earth, that speed feels instantaneous. But space is so unimaginably vast that even at that incredible speed, light takes a very long time to cross the emptiness. Think about the night sky. When you step outside and look up at the glowing face of the moon, you are not seeing the moon exactly as it is in that exact second. You are seeing it as it was a little over 1 second ago. The light from our sun takes about 8 minutes to cross the solar system and reach your skin. If the sun were to suddenly go dark, we would not even know about it for 8 full minutes. We would just keep orbiting a ghost. But as we look deeper into the black ocean of space, that time delay becomes staggering. The nearest star to our solar system is over 4 light years away. When you see it twinkling above you, you are looking at a 4-year-old memory. If we look even further to the Andromeda galaxy, which is our closest galactic neighbour, the scale becomes almost impossible to comprehend. Andromeda is 2.5 million light years away from us. The faint smudge of starlight hitting a backyard telescope right now began its journey across the void before human beings even existed on Earth. This is the ultimate secret of astronomy. Every telescope is effectively a time machine. The further out into the dark we look, the deeper into the ancient past we can see. And the James Webb Space Telescope was not built to look at our local neighbourhood. It was not built to look at nearby stars or neighbouring galaxies. It was engineered to look past everything familiar, pushing through the dust and the darkness, to peer at the absolute edge of the observable universe. It was built to capture ancient, exhausted light that has been travelling for over 13 billion years. Light that was born in the very first moments of creation. To understand exactly what this telescope found, we have to go back to the very beginning, long before the Earth formed, and long before our sun ignited. The universe was a completely different place. Shortly after the Big Bang, the universe was unfathomably hot and bright. It was a blinding, expanding soup of raw energy. But as space itself expanded, the universe began to stretch and cool down. The blinding light slowly faded away. The intense heat dissipated into the ever-growing void. About 380,000 years after creation, the cosmos cooled just enough for something monumental to happen. The chaotic energy finally settled down, and the very first stable atoms were born. This was almost entirely neutral hydrogen gas. It formed a thick, invisible fog that filled every single corner of the expanding universe. But there was a catch. There were no stars yet. There were no galaxies, no planets, and absolutely no sources of light. The fading glow of the early universe was completely gone, swallowed up by the infinite stretching of space. Scientists call this deeply quiet era the cosmic dark ages. If you could somehow stand in the universe during this time, you would see absolutely nothing. It was a pitch-black ocean of gas expanding outward into the absolute cold. There was no light to see by and no structures to look at. For hundreds of millions of years, the universe was a completely silent, lightless void. Nothing was shining, just endless, quiet expansion in the dark. But inside that complete darkness, a slow and patient artist was at work. That artist was gravity. The hydrogen gas was not perfectly smooth across the void. Some patches of the fog were just a tiny bit thicker than others. and in the silent dark, gravity began to pull on those slightly thicker patches. It was a process so slow and subtle, it is hard for the human mind to grasp. Over millions and millions of years, gravity gently gathered the scattered hydrogen together. It pulled the invisible gas into massive, swirling clouds. The dark universe was secretly preparing for something incredible. It was silently setting the stage for the first stars to be born. Deep inside the pitch-black ocean of the cosmic dark ages, the swirling clouds of hydrogen gas grew heavier and heavier. As these massive clouds collapsed under their own immense weight, the pressure at their very center began to rise to unimaginable levels. The temperature climbed into the millions of degrees. And then, in the absolute silence of the dark void, something miraculous happened. The pressure became so intense that the hydrogen atoms began to crush together and fuse. A nuclear fire was ignited, a sudden, violent burst of energy pushed back against the crushing gravity. The very first star in the universe had opened its eyes. These early stars were nothing like the steady yellow sun that warms our Earth today. They were massive, untamed monsters made of pure, raw gas. They were hundreds of times larger than our sun, burning with a fierce, blinding blue and white intensity. Because they were so incredibly massive and burned so intensely hot, they lived fast and died violently. But during their short lives, they completely transformed the cosmos. One by one, like fireflies waking up in a vast and dark forest, more and more stars ignited across the endless expanse. Their fierce light began to push outward. That thick, invisible fog of gas that had shrouded the universe for hundreds of millions of years finally began to clear. The radiation from these massive stars physically burned the fog away, carving out vast, glowing bubbles of empty space. Scientists call this beautiful awakening the cosmic dawn. For the first time in history, the universe was bathed in starlight. The endless darkness was finally broken, and when those very first stars eventually died in spectacular explosions, they forged the very first heavy elements. The carbon, the oxygen, the iron, the deep cosmic seeds that would eventually form planets, oceans, and life itself, were scattered out into the void. But the light from those ancient titans did not die. It set off on a magnificent journey. It left the raging fires of the cosmic dawn and began travelling through the newly cleared space. It swept past newly forming galaxies, drifted through vast regions of complete nothingness, and kept moving forward as the universe continued to stretch and expand around it. That specific light has been falling through the quiet dark for over 13 billion years, waiting for something to finally catch it. Astronomers have always dreamed of looking back far enough to witness the cosmic dawn, but trying to see the very first stars comes with an almost impossible challenge. It is not just that they are incredibly far away, the universe itself is fundamentally working against us. As that ancient starlight travels across the void, something strange happens to it. Space is not simply an empty room. The fabric of the universe is constantly expanding, stretching outward in every single direction. And as space stretches, it physically stretches the light that is travelling through it. When the light first left those ancient stars, it was a brilliant and blinding blue. But as it travelled for 13 billion years, the expanding universe pulled its wavelengths longer and longer. As the waves stretched out, the colour of the light began to change. It slowly shifted from blue to yellow and then to a deep red. Eventually, the light was stretched so incredibly far that it fell off the visible spectrum entirely. By the time this ancient starlight finally reaches our solar system, human eyes cannot see it at all. It has become invisible infrared light. It is no longer a bright beam of starlight, but rather a faint ancient whisper of heat. This is why the Hubble Space Telescope, as magnificent as it was, could never see the very beginning of time. Hubble was designed primarily to see visible light. To catch the ghosts of the cosmic dawn, humanity had to build something completely different. We had to build an eye that was capable of seeing the invisible. That is exactly why the James Webb Space Telescope looks the way it does. If you have ever seen a picture of it, you know it features 18 massive mirrors, arranged together like a giant honeycomb. But the most striking thing about these mirrors is their bright, brilliant color. They are coated in a microscopic layer of pure, solid gold. The gold is not just for show. It turns out that gold is one of the most perfect materials in the entire universe for reflecting infrared light. Those giant golden mirrors are designed to float in the freezing blackness of space, perfectly still, waiting to catch the absolute faintest wisps of heat drifting through the dark. They gather that exhausted, stretched out starlight and gently bounce it into the telescope sensors, finally translating the invisible past into an image we can actually see. When the James Webb Space Telescope finally unfolded its golden mirrors and looked into the deep void, scientists pointed it at a seemingly empty patch of black sky. They wanted to peer further back than humanity had ever looked. They were hoping to catch a glimpse of the very first baby galaxies slowly pulling themselves together out of the dark fog. Based on everything we understood about how the universe works, astronomers knew exactly what they should find. They expected to see small, messy, and chaotic clusters of young stars. They thought it would take billions of years for gravity to build the giant, beautifully structured galaxies we see in our modern universe. They expected to find an infant cosmos, just taking its very first clumsy steps in the dark. The telescope floated perfectly still in the freezing silence, keeping its golden eye open for hours on end, gathering the invisible ancient light particle by particle. And then it sent the compiled data back across 1,000,000 miles of empty space to Earth. When the scientists translated the data and finally saw the image, the astronomical world was completely stunned. The deep void was not empty at all. It was glowing with thousands of brilliant red dots, scattered like bright embers across a pitch-black canvas. But as researchers looked closer at the light signatures, the initial awe quickly turned into deep confusion. These were not tiny, chaotic baby galaxies struggling to shine. They were massive, highly organized structures. They were already incredibly dense, blazing with the combined light of billions of ancient stars. Some of these magnificent galaxies existed just 300 million years after the very beginning of everything. To put that immense scale into perspective, if the entire 13 billion year history of the universe was compressed into a single 24-hour day, these giant galaxies had fully formed in the very first seconds of the morning, according to all of our carefully crafted mathematical models, and everything we thought we knew about the slow and steady laws of physics. What they were looking at was completely impossible. For decades, astronomers have relied on a very specific timeline to understand how the cosmos grew. The standard model of the universe is built on a very simple, yet intuitive idea. It dictates that grand, magnificent things take a very long time to build. According to this accepted timeline, gravity is a slow and methodical worker. After the first stars ignited, they were supposed to group together into very small, messy clusters. Over hundreds of millions of years, those tiny clusters were supposed to drift toward one another, slowly colliding and merging in the dark. It is a process of cosmic assembly that requires an immense amount of time. It takes billions of years of these slow-motion collisions to finally build a mature, spiraling galaxy like our own Milky Way. But the glowing shapes captured by the James Webb Space Telescope completely shatter this slow and steady timeline. Some of the ancient galaxies glowing in that deep field image are staggeringly huge. They contain the mass of tens of billions of suns. They are packed with mature red stars, which are stars that have already lived long, full lives. But according to the age of the universe at that time, those stars should not even exist yet. It is like looking at a photograph of a newborn nursery. and finding a fully grown adult staring calmly back at you, or planting a tiny seed in the ground at sunset and waking up the very next morning to find a massive, towering oak tree casting a deep shadow across your yard. There simply was not enough physical time in the universe for gravity to gather that much matter together. There was not enough time for that many stars to be born, to live out their long lifespans, and to settle into these massive, luminous cities of light. The physical math of the cosmos, the very equations we have always used to understand reality, suddenly do not add up. We are missing a massive piece of the puzzle. And this is where the true, awe-inspiring beauty of science reveals itself. We did not find a mistake in the golden mirrors of the telescope. We found a profound gap in our own human understanding. The universe is proving to be far more efficient and far more mysterious than we ever dared to imagine. Only grew darker and more profound. It was not just the mature stars that defied explanation. Hiding in the very center of these ancient structures, they found something even more terrifying and beautiful. They found supermassive black holes. A black hole is a region of space where gravity is so incredibly intense that nothing at all can escape its pull, not even light itself. In our modern universe, we know that these massive gravity wells sit at the center of almost every large galaxy, anchoring the swirling stars like a heavy stone dropped into a quiet pond. But just like a mature galaxy, a supermassive black hole takes a staggeringly long time to grow. They usually begin their lives as the collapsed core of a single dead star. Over billions of years, they slowly consume the gas and the cosmic dust swirling around them. They feed on stray stars and merge with other black holes, steadily gaining mass in the quiet dark. To reach the size of a supermassive black hole, millions or even billions of times heavier than our Sun, it requires billions of years of constant, patient feeding. Yet the James Webb Space Telescope found these absolute monsters existing in the very dawn of time. They were already fully formed, blazing with the brilliant light of the matter they were actively consuming. Just like the galaxies surrounding them, they were far too massive to exist this early in the story of the cosmos. How did these massive gravity wells grow so huge, so incredibly fast? Did they form from the direct collapse of giant clouds of pure gas, skipping the star phase entirely? Or is there some deeply hidden physical law, a fundamental secret of gravity, that allowed the early universe to build giant structures in the blink of an eye? We are standing on the edge of a completely new frontier. The ancient light captured by those golden mirrors is quietly forcing us to rethink everything we thought we knew about the deep past. The universe is speaking to us through the dark, telling us a story that is far richer and far more complex than our simple human equations could ever predict. We do not have all the answers yet, and when you truly think about it, there is a profound and comforting beauty in that unknown. In a modern world where we feel the constant need to understand and control everything around us, the deep universe offers us a gentle reminder. It is perfectly okay to simply observe. It is okay to not have all the answers. The cosmos is still vast enough and wild enough to completely surprise us. The impossibly massive galaxies and the ancient black holes discovered by those golden mirrors are not a failure of our science. They are an invitation. They are a quiet call from the deep dark, reminding us that the universe is still full of magic and mystery. As you lie there tonight, let your mind drift outward. Leave the gravity of the earth behind you. Picture that single particle of ancient light, born in the raging fires of the cosmic dawn. It travelled for over 13 billion years through the absolute, freezing quiet of the expanding void. It crossed an endless ocean of nothingness. Completely alone in the dark, It travelled all of that way, across all of that immense time, just to reach us. Its long journey is finally over, and just like that ancient starlight, your long day is over too. It is time to let go of the heavy questions, and let the quiet momentum of the universe carry you forward. The stars will continue to burn, the distant galaxies will continue to slowly spin, and the void will continue to gently expand in the dark, all without you needing to do a single thing. For those of you still drifting on the quiet edge of sleep, there is one final, beautiful scientific truth to carry with you into the dark. The story of the early universe is not just a story about distant space. It is the literal history of your own physical body. When the cosmos first expanded out of the dark ages, it contained nothing but simple hydrogen and helium. The early universe did not possess the materials required to build solid planets, rushing rivers, or biological life. The raw elements of our physical world simply did not exist yet. To create the world you know today, the universe had to go to work. Those very first, impossible galaxies caught by the golden mirrors were cosmic forges. The giant stars blazing inside them spent millions of years under unimaginable pressure, crushing simple hydrogen atoms together to build heavier elements. And when those massive stars finally ran out of fuel and died in spectacular explosions, they cast those newly forged elements out into the endless void. Every single atom of carbon in your cells, every trace of iron in your blood, and every breath of oxygen filling your lungs right now was manufactured in the blinding core of a dying star. Over billions of years, those scattered elements drifted across the quiet cosmic ocean. They slowly gathered together in a quiet, spiraling arm of the Milky Way, forming a swirling cloud of dust that eventually cooled and condensed into our sun, our Earth, and ultimately you. You are not just a separate observer looking up at the night sky. You are the universe itself, waking up for a very short time to look back at its own beginnings. The iron in the center of the Earth is the exact same iron flowing through your veins. So as your breathing slows down and your muscles completely relax, remember that you are exactly where you are supposed to be. You are made of the very same ancient stardust that those golden mirrors are looking for. You are a piece of the cosmos, finally returning to rest. As the ancient starlight captured by those golden mirrors fades back into the timeless dark, we thank you for listening with us tonight on Nightly Notes. If you found a moment of peace among the stars, consider subscribing to join our quiet journeys across the cosmos. Until the next sunrise, take care of our fragile blue world, be kind to one another, and sleep well beneath the infinite sky.